life. Thank you for protection of our lives, Lord. We welcome you of everything that you're going to do. Help us analyze it, Lord, and bless our teachers and our parents too. In Jesus' name I pray. Amen.
Amen. Thank you so much, Adu. I will be starting from here, and I want to welcome you all to this lesson for mathematics. This is week 2 at the Holistic Learning Platform. I will assume you attended the previous week, and at least you've not remained the same. I also want to welcome you back from your schools, and the assumption is that you excelled wherever you are. This afternoon we'll be talking about mathematics, and maybe before we talk about what I've prepared, I wanted to remind you about the syllabus for those who read using the syllabus. This is term 2, the term that we are going in. The term that we're going in is term 3, and we expect all of you to have at least covered some of the things that were captured for term 1. And among term 1 activities, you must have at least got some knowledge on the equation of the straight line, some trigonometry, and data collection, then some vectors. Vectors was a continuation of what you studied in senior 2. So this holiday we'll be reviewing term 2 work because many schools have not yet even reached term 2. We can't pick something in term 3. And we'll be picking matrices as one of the work that we'll be reviewing. For those who have covered already matrices, you're good to go. And for those who have not covered, we are going to have it repeated such that you can pick something, and when you go back to school, you have at least something. In the previous lesson, you must have reviewed trigonometry. I saw the work being posted on WhatsApp, and I expect you to have read further than what was taught. So we expect you to have at least covered part of term 2. If not, maybe you're going to start it for those schools that are moving a little fast. But I know there are some schools that are still covering book 2. If you are here, still you're safe, because what we're going to talk about will not need much knowledge from book 3, but it will involve simple additions and subtractions, which knowledge you already have. I also wanted to remind you about today's program. And today's program, it's a Wednesday, and we expect you to have math, and you'll have some ICT course. For those who are following it, you must have known what is happening that side. I want to encourage all of you to go there, because the curriculum we are covering, if you don't have the ICT knowledge, then it's a little difficult and you'll not manage to navigate through. ICT is almost integrated in all subjects, so holistics gives you that chance to try out some of the possibilities in the world of ICT. I also wanted to remind you about the pretest exercise that was going on, where I teach here. Our students were picked to do one of the papers. I expect you to have maybe been picked as well. And if you did, I hope the experience was good. If you didn't do, there is this option I was reading about the other day. If you didn't do, okay, even if you did, I know there is no school that did all subjects. There is that option that will be in the new vision. They started putting those papers on Monday. They put Monday, math and geography. So maybe you may need to see a new vision paper if you can afford to buy a copy. If you can't afford, you can just photocopy that particular part such that you have a feel of how students tried to respond to some of these question items if you didn't do. But if you did, you may get a chance to see what could have been correct and what could have been wrong. It is still continuing up to when they will post biology, and that will be online. I think all of us will be still in holiday. So get to use that chance and read about what UNEP is thinking of setting for you at the end of the year next year. So we expect you to prepare very well and you excel. I'll be picking out one of the activities. Can you please talk a bit louder? I don't know if you're able to hear me. Someone, are you able to hear me?
Your volume is kind of low.
I don't know where the problem is.
Sir.
Are you able to hear? I want to try out this.
Not proper, sir.
Okay, I was trying to say that these pre-test exams have been put in the new vision. For those who can afford to buy the copy, well and good. If you can't afford to buy a copy, then you can get a person who has bought and you photocopy. Don't go back to school without reading through what UNEB intends to set for you next year. Is what I was trying to emphasize here. I also talked about today's activities. We have math, then the ICT course will be coming up next at around 3:30. So make sure you have enough data to make sure you don't miss out any of today's activities. Zoom in. I'm going to just share that picture. It's hard to zoom in. Maybe if you can zoom in using your phone. But there is nothing important on that picture apart from the days, which is 4th to 9th. So you can start buying those papers. You don't need to zoom in to see what is there. But I will also share it on the WhatsApp group such that you can maybe share with people who are concerned. They see if they can get for you a copy. So I want to welcome you again to this lesson and welcome you from school. And for those who excelled, we congratulate you. And for those who didn't get very good marks, we still have time to get there. So I had shared this syllabus outline for Senior 3, and I said we are trying to review term 2 work, and specifically we picked out matrices in today's lesson. I expect you to have an idea of all what is here. If they have taught, if they have not taught in your school, then you should just write these topics down such that maybe you can try to read maybe ahead if they're not very hard. If they are hard, you can skip and wait for the teacher to come and maybe explain it better. So we'll be starting from there and we'll be talking about matrices, and this is from data and probability, and the competency is very clear on that screen. And specifically here, we're going to see how to work with matrices and to use matrices to solve a few problems. And one of the problems that we are going to solve is if you're given matrices, are you able to work with them? And working with them here, we look at, can you add the matrices? Can you subtract them? Can you multiply matrices if you've been given such a problem? And if you've known how to do all that, can you use matrices to solve a problem? And the problem could be maybe a person is buying items. They can give you some scenario of a person buying items in the market, maybe in terms of kilograms or in terms of liters. Maybe they can tell you they are comparing town A and town B on how they sell items. Can you use matrices to try to understand such a problem? And if you can understand, then you need the knowledge of how to do the operations on matrices like addition, multiplication, subtraction, among others. And it's what we'll be talking about this afternoon. And in this chapter, there are about 5 objectives. I may not read through all, but the 2 are the most important that we'll be talking about in this lesson. And the first one will be the definition of a matrix and stating its order. We'll see how to do that and knowing when a matrix can be added or multiplied. So in today's lesson, we'll majorly concentrate on those first 2. Can you define a matrix? If you can define it, if they give you a sample matrix, are you able to tell its order? What does the order mean, first of all? Then what is a matrix is what we'll look at. After that, we'll see how to do operations on matrices, and that could be addition, subtraction, multiplication, and the big question here will be that part B, and it will say, if given matrices, when are they supposed to be added? Can any matrix added or subtracted? If it is true, now look at that. Let's okay, so we want to understand matrices. So yeah, correct that. We're talking about matrices in this lesson. I started by sharing an activity earlier on in the morning, and I expect you to have read about matrices. And by show of hands, if there is anything you've read about matrices, you can just post it, maybe type it in the chat or put up the hand and tell us that I read about this. Or you can type it in the chat and I see how far people have moved based on that activity that was shared. But putting up the hand would be better, such that you don't do more of listening, but if you can talk at some point, the better. In the activity that I posted, I wanted you to define a few things. I was trying to look at some people's work, but again, the last question seems to have been out of order, but we'll see how to handle it as well. I'm still waiting to see if anyone read about anything here. Are people here even? Joshua is saying something. A matrix is an arrangement of numbers in columns and rows. Joshua tried to read something about the definition of a matrix, and that one is very good. Is there anyone who read about anything about matrices? I had given you an idea of how you were supposed to read if you didn't know what to read completely. I'm waiting to see some other person. Okay, you may have not read about the matrices, but if there is anything you know about matrices, maybe you can also put it in the chat. Or is there something you want to know about matrices? You can also leave it in the chat. Matrix is a set of numbers arranged in rows and columns. Yes, Brina has something as well. And then Kenneth is saying a matrix is a rectangular array of quantities or expressions in rows and columns that is treated as a single entity, manipulated basing on the particular rule. Okay, Kenneth seems to have also read much about the definition of matrices. Then someone has no name here. Types of matrices, types of matrix, elimination method, substitution method. Now this one has no name, but must have read about the types of matrix. He has also reminded us here of the one is to do with the simultaneous equations, hope so. And elimination method is not for matrices, but at least you've reminded us about that. Then substitution method is also another approach to solving simultaneous equations that may not be using matrices. And Joshua still says, is the arrangement of numbers in the rectangular form? I don't want to agree with that for now. Joshua, a rectangular form? I don't know why you want to again narrow down the definition. You had a better definition earlier. So the one that you're putting again seems to be going a little away from the definition. Sharon Oprah says a matrix is a rectangular array. I don't want you to say rectangular. I feel you'll be definition. A rectangular array of numbers, symbols of expression arranged in rows and columns. Sharon Oprah has something also. I don't know if you can hear me. Are you able to hear me?
Yes.
Okay. Sharon will see the definition of matrix, but I don't like it when you call it rectangular, because we have some matrices that they're square, maybe have rectangular. So maybe you're only defining one type of matrix here. So there is that good definition that we'll see. Matrices are multiplied in rows by column. Faith has an idea here as well when it comes to multiplying matrices. We'll also see how to apply that. Is the orderly arrangement of numbers. Now, someone using Techno-Common 15 is the orderly arrangement of numbers. Now, what qualifies the definition of matrices, if you can talk about rows and columns? So if this could be a definition, someone using Techno-Common 15, maybe you would have missed out a very important keyword. Brina still comes up with something, arrangement of numbers. Okay, I'm not talking about the definition of matrices, anything you know about matrices. I see people are concentrating much about the definition. Mike also has the definition. Kenneth, okay. You said earlier, such about topic. Did you share? Brina, I did not understand that, but I shared that work on WhatsApp. So maybe you'll have to scroll through and see. Joshua has something, Sharon has something. So basically that is it. We want to understand matrices, and we're going to understand matrices using this activity that I'm going to post here later on, but we're going to base on some of those definitions you've come up with, and we see if we can understand matrices before we can later on use them to maybe add, subtract, and do something else on matrices. And the activities here, you're supposed to study this table as it is shown, and it is talking about the kilograms being consumed in 1 week by different families. You can see different families. We have about 4 families here, and they are trying to show us how they spend their maize flour, that is maize flour. Then we have sugar in kilograms. Then the bread is also in kilograms. We see that in column 2, column 3 here, Mwanga's family is spending 2 kilograms of, they are consuming 2 kilograms of bread, and you can see 9 and somewhere like that. So this is a normal table that you can also come up with if you go to the field and you're finding out how many kilograms are consumed in different families. So you can develop a questionnaire that looks like this. It has maize flour, it has sugar, it has bread. You go to Mafabi's family, you ask them how many kilograms they consume, they tell you. So let this data not look very abstract to you. This one can be corrected from anywhere you can go. So the big question here is that describe the consumption of sugar in 1 week by families. They want you to describe the consumption of sugar in the 1 week by families. So we want you to look at that table and see if you can manage to describe how sugar is consumed in 1 week by families. And that is our first big question. And by show of hands, if you've understood that question, can you try to describe for us how sugar has been consumed in 1 week by families? You can just read through again and try to understand that. If you understand how sugar is consumed, you put up the hand and tell us. Later on, we are going to use the figures. We are going to use the figures here in this table, and we are going to reorganize them without tables. And then we'll proceed from there. So, who can give us part B of that question after studying that table? Have people forgotten to put up the hand, or what is happening here? I have not seen anyone put up the hand. Okay, I can't see any hand up. I don't know what that means. Is the question very hard?
Describing the consumption of sugar in 1 week by the families. We notice that in Mafabi family, Mwanga family, Opio family, and Cherop family, the consumption of maize is highest in terms of comparison with sugar and bread, because Mafabi family has 8 kilograms, Mwanga has 9 kilograms, then Opio has 6 kilograms and Cherop. But when it comes to comparing the consumption of sugar and bread, Mafabi family and Cherop family, Mafabi family, Opio family, and Cherop family consume less sugar compared to, less kilograms of sugar compared to the kilograms of bread. Unlike Mwanga family, which consumes more kilograms of sugar than bread. So that is the comparison, and there is a descending order in Mwanga family than the rest. I think that's what I've noticed.
Okay, Ruth has that observation and it's trying to show us that there is a descending order in Mwanga's family that is from 2, 3, and 9. Yeah, it's a good observation, and she has tried to compare how sugar is consumed, maize and bread in different families. Any other trial? Brina, you seem to be having something. Okay. So depending on how you see this consumption, but what is very important here is that they have given us maize, sugar, and bread. So you're supposed to compare these 4 families, and you come up with a description of how sugar is spent in the first 1 week. And what I expect you here is to tell us that sugar in 1 week, Mafavi's family takes 3 kilograms, Mwanga takes 3 as well, Opio family takes 2, and Cheropu's family takes 4. I want to hear something like that. And the interest of this question here is to see if students can use that table and understand what is happening in different families. So the second question here, the third question. The third question here is saying you're supposed to write the figures in an organized form without the tables. So if you were to avoid writing the tables, if you're to avoid using the tables here, is there any way you can rewrite these figures and it still has the same meaning? Is what this question is trying to mean here. And if you can manage, you can put up the hand and you can put up the hand and try to tell us how you can write the same figure without changing the meaning of this table. Or alternatively, if you know how to annotate, all of this place is free for you to rewrite these figures without changing the meaning of that table. Faith, do you want to try?
Yes, teacher. Teacher, according to me, I think we are going to use row by column method, whereby we are going to put for maize in one column, sugar 1 column, and then the one for bread also in 1 column.
Yes, she's telling us that we are going to put for maize in 1 column and maize in 1 column, then maize. Okay, I want to write maize here. Maize in 1 column, sugar in 1 column, then bread in the other column, if I have understood what Faith wants to do. And she's trying to say that for maize, we have 8, we have 9, we have 6, we have 7. That is the first column according to her. And for sugar, we have 3. This is 3. We have 3 again. We have 2. We have 2. Then we have 4, like this. And then for bread, we have 4. We have 2. We have 3 as well. Then we have 5. Yeah, that is according to Faith's understanding of how to rewrite this without using a table. And she has tried to organize it like this. I don't know whether it still makes sense or it has lost the meaning. Any other trial? Any other person wants to try rewriting the information that is in this table without using the table and it doesn't lose the meaning? Okay. Is there any other person who want to try to rewrite this? Ruth, what would you do?
What about if we just eliminate the the lines, the way that the table is, and then we have the families as the different families as the subjects instead of maize and sugar being the subjects. We have Mafabi family 834, Manga family 932, all in columns. Then Opio family 623 and Cherub family 745.
Okay, that is another good suggestion about when we maintain the table the way it is and we avoid just those rows and columns like this. Let me try to write it here and see if we can maybe subject it to votes and we see which one would be the best alternative way of writing this. Ideally, these are the only two possible ways you can have this written, but which one is the best you can write? This is Mafabi's family. We have Manga's family here. Then Opio is here. Chiropu's family is here.
10 as the and
Okay, so that was Ruth. She
Trevor,
seems
your
to
hand is up.
Okay, Trevor, you can go on.
Yes, so I think that one, the first one is okay, because the question here is asking that describe this consumption of sugar in 1 week by families. Now, if you see the second one here, it's only because of the family names, not the things which, okay, the quantity like of the sugar consumed by the family. I
Okay,
think the first one is good.
Okay, Trevor has the first one as the best alternative we would use. But again, according to what you have said, even the first one doesn't have the family names. It only has the sugar, but it can't show us which family is taking, for example, to which family is taking for. Even this one does not have what is being consumed. It only has families. So maybe you realize that if we are to use what Trevor said, we may end up discarding all the two. There was that hand. Which hand was that? Trevor is observing. Okay, we are going to
Mike's hand that he keeps on
Yes.
lowering it.
Okay, Mike, you can try one more time. I'm going to call this. I'm going to call this B, that we can be able to call the options by name. Mike, you can go on.
I think you can use annotation whereby you put the different subjects, which are maize, sugar, and bread. Then you divide them. Like, let me say this is the main subject, maize. Then you put an arrow going to Mafabi's family, which has 8. I mean, for sugar, we put 3.
Mike, are you trying to talk about A or B? Which one? Such that we follow what you're saying.
I'm talking about C.
You have C. Okay. Let me write yours as well. You're saying?
I'm saying you can annotate according to the 3 items that we have. We have maize, sugar, and bread. So if we can annotate, then let me say on the part of maize, we put an arrow going to Mahavi's family, which shows 8. Then another arrow going to Manga's family, which shows 9. Opio's family, which shows 6, and Cherok's family, that shows 7.
Not understood well how you are supposed to write what you're saying. But
it can work as an arrow diagram.
Like what?
He's saying
it can work as an arrow diagram.
He's
okay. Ruth, you seem to be
Mr.
not.
Masawa, what he's saying is that he's going to we can attach the names of the families by putting arrows, like how we use direct proportion and then we have those arrows. Then we have Mafabi's family to indicate the kilograms of maize, sugar, and bread. And then we have on this second row, we attach Mwanga family. On the third one, we attach Opio family and Cherop family on the fourth. I think that's what you are saying.
Something like an arrow diagram, like this.
Yes, that's what you are saying, the arrow diagram
This
aspect.
is the
Mic
very
unmute.
Okay.
Yeah, that's what I was saying. The arrow diagram can
Yes.
work like the ones we use in mappings and relations.
Okay. So how do you come up with this?
Mic, the floor is yours.
You can make 3 of them, whereby the first box or rectangle has maize. Then it will be a 1-to-1 map. Then the second one has sugar. The third one has bread. So in the first one, we put Mafabi, Mwanga, Opio, and Cherop, like we put the families.
Mm.
Then in each of them, we draw arrows. Like in each of the rectangles, we put all the 4 families.
Mm-hmm.
And then after we draw arrow diagram starting from maize, we put the ones representing Mafabi, then we put 8, then the ones representing Mwanga we put 9.
So where do we put the 8?
We just draw an arrow diagram from M.
From M here? Okay.
Yeah.
Okay, maybe because of time, I would love to really follow this and see where it ends, but because of time, we will have it end there. So, but if you have a sketch that you've used, if you can take a photo, such that later on you'll share with us, and I try to look very well. I seem to have picked interest in this. I want to see how alternatively you can use mappings on this, but for now, we may first hold it. Let's concentrate on these first 2, at least. They can also give us a picture of how to rewrite this table without using the rows and columns. So someone had said that he would rather take A because it is showing the sugar, it is showing the maize, and it is showing bread here. He would rather take A. And he was claiming he can't take B because it was not clearly showing the items consumed. Now, I want to subject this to a vote because of time. I want to just have a feel of how people would take up this. Can we maybe try to vote from the chat? If you're to be given that, you'd take which one? Someone had already picked A. And I want to see how many people pick A, how many people pick B. Faith has A. Everyone here has A. And A seems to be having majority. For now, Kezia has A as well. Immaculate has A. Sarah has A. Isaac Newton has A as well. Chirabo Hannah A. Kenneth has B. Okay, there is a poll here. Let's choose directly from the screen. Let's choose directly from here. A or B, A or B. 9 people, 11 people have A, B has 1. Okay? B has 1 so far. Let's not use the chart. Take common 15. Check on your screen, there is that poll. Just pick from there. Okay, at least I've seen how people would wish to vote here. And I'm going to end the poll here. The question would expect you to pick either A or B. And majority of the people are picking A because of their reasons. Now, I want to end this poll. And make a generalization here. Why pick? Someone is saying why pick? Okay, I wanted to see how people would vote if you're given this question to write the same table without rows and columns. And we had Faith who gave us this first option, and Ruth was wondering if she wrote like this, would it also have the same meaning? And I want to say that both A and B are correct, but now what makes A or what makes B the correct alternative is if the examiner specifies which order they want you to write the matrix. That one was in our introduction where I talked about the definition of matrices and the order. So this matrix and the one down here, they are the same, just that the other one is of a different order and this one is of a different order. She chose to start with the columns being inverted, and here she's maintaining the columns. So they are the same. So for you to understand if the question is set, they will always tell you, come up with a 2 by 2 or 2 by 3 or something like that, depending on the orders. So for now, if A is what you picked, I want to improve on it and say you would write it like this. This is what I would expect you to do. And I'm going to, to put it somewhere here. I wanted to put it where I can see. I want to put it here. We are picking A and improve on it to be the correct one, and I'll also show you how you would have written B correctly. So if you're to write it without changing meaning and you're using the first alternative, then you're supposed to put the maize here, you put the sugar, then you put the bread here. Then you're supposed to go ahead and tell us the families here, that this first family is for Mafavi. I'll put that later on, but this is 8, this is 9, this is 6, this is 7, like that. Then here we have 4, 2, 3, 5, like that. This is 3, 3, 2, 4, like this. So we are supposed to write it like this and put it into 2 big brackets like this, such that it shows something that is looking like this. And here means these rows are how many? 1, 2, 3, 4. There are 4 rows here and they are representing the 4 families. So you can go ahead and name these families and say this is Mafavi and say this is Mwanga family, and this is Opio, and we have Chiro here, like that. You can go ahead and add that, or you can even leave without putting that, because then the whole information is being extracted from a table that is known. And if you were to use this other method, this other alternative that Ruth had given us, here I want to encourage you to just put this something like this to enclose your values. Later on, we will know the name given to this, but these ones, maybe before we even get there, are called entries. And once you enclose it like this, it forms what is called a matrix. And a matrix, according to the definitions, it must be a representation of values in terms of rows and columns, like most people were trying to define. So we have so many examples of matrices that you can imagine of. You can think of something like this: 5, 4, 3, 2, like that, and close it like that. You can think of something like this: 1, 2, 4, 7, and close it like that. But then something like this cannot be a matrix, like maybe 1, 5, 4, like this cannot be a matrix because we don't know the value you're supposed to put here. And if you're to check, well, if we are to use this table, then 1 could be for a certain family, maize, then 4 could be maybe for Mwanga's family for maize, 5 could be for Mafavi's family for sugar, but here you've not mentioned anything. It ceases from having meaning, because if you're to compare, if you're to remove the table, if you're to eliminate the table, then the meaning must be not lost. So there is no matrix that can be written like this. So if it is writing a matrix, then it should have all the values. And when you are writing the matrix, at the back of your mind, put this table behind. It is always a table you're representing, but you're just avoiding drawing the physical rows and columns. So that is what I felt you should know before we start talking about matrices. So the red is not clear. Yes, the red is not clear. I also realized that's why I wanted to avoid it. So that is it, basically. And if you've not seen it clearly, at the back of your mind, whenever you see a matrix, know that there is a table they are trying to represent. Whenever you see a matrix. So if there are 4, just know there are 4 columns. If there are 2, like that. So don't always look at matrices as very abstract things. No, it's a table that is representing information in rows and columns, but they have avoided drawing the physical table. And the other question was, describe what 9 and 5 in the above represent. Describe what 5 and 9 represent. 5 is here, then 9 is here. Who is describing for us what any of those ones mean? By show of hands. Okay, why use matrix? Why use matrix, yet the table is enough to show the information? Shirabo has a question and she's wondering, why do we go ahead and use matrices and yet the table is clearly showing us what necessary, well, what is already being captured? Why do we use matrices? We use matrices because it is a whole topic in mathematics, and whenever you've also covered topics in any subject. So whenever they are covering a topic, there are so many things you should do and you should not do. For example, if you're adding, matrices are going to have an order of how to add, and you should learn about it. For example, if I wanted you to add using this table, maybe it will be easy if the data is not much. But if the data is abstract, if the data is much, then it is going to be very complicated for you to add. Maybe adding would be easy, but when it comes to multiplication using a table, you're going to get a lot of problems. That's why we represent our table using matrices. And matrices will help you to solve abstract problems, like someone was talking about simultaneous equations. Unlike when you use a table, it will not help you to solve such a problem. Ruth, there is that hand up. Ruth, do you want to say something?
Okay, the first, yes, I was asking for the I am asking for the applications of matrices in daily life.
Okay, the applications of matrices in daily life, that one will come later on. But like I told you, it helps you to sort of abstract things like the examples I'm going to show you later on. And in daily life, we need to also first understand how to multiply and how to maybe subtract matrices. Then we can see how to use them later on in the daily life. There is a full lesson for that. But here what I can maybe tell you is to hold on a little bit. I was still talking about the 9 and 5. The question says you're supposed to describe what the 9 and 5 means in the above table. Now, 9 and 5, as someone is preparing to tell us what 9 and 5 means, I'll re-represent this like this. The red wasn't clear. Let me see if I can use a different color. Black, like this. Someone should be preparing to tell us what 9 and 8 means. And I'm writing 8, 3, 4, 9, 3, 2, 6, 2, 3, 7, 4, 5, like that. What does the 9 mean and what does the 5 mean here? Who has seen that? Yes, Julia?
So I'm trying.
You can go on.
Yeah, I think the 9 shows the amount of kilograms of maize consumed in 1 week by the family by Mwanga family, and then the 5 shows the amount of bread in kilograms consumed in 1 week by Cherop family.
All right, that was Julia, and she was trying to talk about what 9 and 5 means. And I must say, she has really given it her best. And Chirabo has something in the chat, and she's saying, I think the 9 and 5 represent the highest consumption of maize, and bread represents, okay, the highest consumption of maize and bread respectively. Okay, she was trying, she's saying 9 represents the highest consumption of maize and 5 represents the highest consumption of bread. And that one also has another version of what 9 and 5 means. And whereas Julia was telling us that 9 simply shows how Mwanga's family is consuming the maize in terms of kilograms, and 5 represents how Cheropu's family is consuming bread in kilograms. Yes, Ruth, you have something? Then Kezia has 9 represents the kilograms of maize consumed by Mwanga's family. Kezia has almost the same idea like what Julia has. Ruth, what do you have to say?
Okay, me, I'm supporting Chirabo. My answer is related to Chirabo's. It's the same actually, because by the time they selected out 9 and 5 and ask for what they represent, then the analysis is that we look at the families, 4 of them, and you notice then 9 is the highest in amount of kilograms. And then when we look at 5 under bread, we find it as the highest in amount of kilograms. So there we now join to contrast that in 9 it shows the highest consumption of maize kilograms and the highest consumption of bread kilograms. So I was just supporting Chirabo's answer.
All right, thank you. Ruth also supports Chirabo. And Julia also has about 2 people in the chat supporting her. And what I can say here is that what this question wanted to show us was the highest in each category. But of course, if they tell you to describe what it represents, you can say the 9 shows what exactly maize, well, how much maize is eaten by Mwanga's family. So she has a point. But the whole thing is here. If you're given a matrix like this, 4, 5, 3, 2, like this, what this D is helping us to understand is that these values don't come from the blue. Every time you see a 2 is representing something. Like you see a 9 here, this 9 is the one that is here. Even without the headings up, it is not just picked. It must be representing some value. It could be representing the maize eaten by Mwanga's family, or it could be representing the highest consumption of maize in the 4 families. So they have never, they don't just pick these values from the blue. When you see 5, it has something it is representing from a table at the back of your mind. So when you're writing 5 and for you write 3, you have changed that information and you would have done a very big error. So I want to encourage you to always look at matrices as if it has some information it's portraying, and exactly when you're to compare this 9 and 5, they have not been just picked from the blue. The first group says 5 is the highest for bread and 9 is the highest for maize. Alternatively, the other group says 9 is the consumption of maize in a certain family. So it is never picked from the blue. It must have where it is coming from. So that one introduces us to matrices, and allow me to proceed to the next slide that has some of the terms that we are going to look at in this chapter. The terms that we're going to look at in this chapter are the matrix, are the following. The first one is matrix itself. If they ask you to tell or maybe to briefly explain what is meant by the term matrix, many people had talked about it in the chat, but the 2 keywords there is representing information in terms of rows and columns. And you people, every time we talk about a matrix, then it's plural. Is matrices if there are many. If it's 1, then it's a matrix. If it's more than 1, then we call them matrices. We'll talk about matrix throughout the lesson, but the chapter is matrices. Then a person would wonder, are these 2 different topics or what? And a matrix is written like that. You people, a matrix is always represented by a capital letter. If it is A, then it has to be capital. If it is B, it has to be capital. And the values inside, like you can see the A and B are always small letters. What I can also emphasize here is that when you're writing a matrix, always put it in this type of brackets or the other brackets that you saw me use previously, the brackets that look like this. You can either use this or you can use this. Don't write a matrix and leave it in open. You would have not written the right thing. And the values inside here should always be small letters. Ruth, that hand is up.
It's my hand. I was asking what is coming across, or what are you trying to put across by using letters? Does that mean that a matrix also can be represented using using letters, because you're emphasizing the lowercase and the uppercase formats?
Yeah. Does it mean that represent information is not even demanded, right? I've not understood that question in the chat. Okay. Gundi, Ruth says, why am I talking about letters? Yes, we are going to use letters later on.
Pardon?
I'm saying I'm using letters because the previous examples were using values. And when we are talking about matrices, we can't avoid using unknowns. Later on, you will see where it is coming in. And every time you think of using unknowns in a matrix, then don't use capital letters.
Okay. Thank you.
There is this statement for Trevor in the chat that, does it mean that you represent information using matrices when demanded? Yeah, if they demand you to use matrices, to represent information, start by drawing a table, then extract that table into matrices. Trevor, that is what I would think of. Your hand is still up, Trevor. You still want to ask something? Okay, so the other alternative, the other example could be like this. Trevor, what is that? Okay, kindly put down the hand, Trevor, if the question is not coming up, at least in the chat, I read the question.
So, yeah, it is a problem. Yeah, just a second.
Okay, Trevor, I had to close your microphone and I'm going to lower the hand from here because the question was clear in the chat. Unfortunately, your network can't allow you to speak. So a matrix can be represented. You can use unknowns if they ask you to maybe determine some values and you want to use matrices, you may pick unknowns. You are supposed to use small letters. And if you are to get a problem that has negatives, matrices are not only limited to positive numbers, they are also negatives. You can also use that. Another matrix example can be this: x is equals 3, 1, 5, 2. And what I want to emphasize here is that this 3 is representing something in a certain table. That's why it is here. It is not picked from the blue. And maybe this is 1, 2, 3. There are 3 examples of matrices here. In your books, you can come up with any other matrices. You can get one and call it matrix P. And you say matrix P is equals 1, maybe 3, 0, 5, like that. You can think of any matrix provided it is having sense. If you're to use maybe 1, 2, 5, then even down here we must have maybe 4, 3, 1, like this. It has to be complete, and this could be an example of a matrix. Yes, someone wants to say something?
Master, can you have a 3 by 5 column matrix?
Yeah, that is when it comes to orders, we'll also see how to do that. 3 by 5. 3 by 5. This one means there are 3 rows, like maybe 1, 2, 3, 4, 5, 6. These are 2 rows. You are supposed to add another one here to show the 3. Then you're supposed to put 5 columns. 1, 2, 3. These are 3 columns. Maybe 5, 2. These are 5 now. 5 columns. Then you make 3 rows downward here like that. We will see. Those are called the orders of matrices. I don't want to talk about it now. Julia?
Yes, teacher, like you've talked of 3 by 5. Do those columns and like the rows have limitations? Or you can do anything like 3 to 9, 3 to 5, 3 to what?
They don't have limitations. I think you saw the table. It had bread, it had sugar, it had maize. You can add tea leaves, you can add, like it is unlimited, unless if the examiner restricts you to a certain order. Maybe if they tell you write a 2 by 5, something like that. So those are some of the examples of how you can write a matrix in any format. Someone has already peeped into how to write it using the orders. But here I was trying to just show you some of the examples of matrices. And in the next slide, we'll continue to talk about an entry. An entry is also referred to as an element. And you can see that there is 2, 3, 4, 5. These ones here are called the elements of a matrix, or it is called an entry. So we have 4 of them here, and the numbers 2, 3, 4, and 5 are the elements of the above matrix. This is also a very important term. They will tell you about the entries in a matrix or the elements of the given matrix. They mean the values that are inside it. So the next term, maybe you'll be taking screenshots because of time. Don't struggle to write everything. The next term, and very important term, is what we call the row of a matrix. The row of a matrix is not very different from the normal rows that we have. So a row of a matrix is always red going this side. If the matrix is looking like this, for example, this one here, 2 and 3 are representing rows. Then the other one represent columns. So rows, these are lines of numbers that go across the page. Now, when you consider this example of a matrix, the values that represent rows is 2 and 3, that is the first row, and 4 and 5, that is the second row. So a row of a matrix is going to be a very important term that we are going to use. Kindly don't forget it when we reach the application. So the next one is, okay, there is a statement down here. 2, 3 form the first row, 4, 5 form the other row. Therefore, the above matrix has 2 rows. There is a very important statement down here. I had talked about rows, but I did not emphasize which one is the first and which one is the second row. The first row has 2 and 3, and the second row has 4 and 5. So this matrix only has 2 rows. So maybe I'll write a matrix here and you tell me how many rows do we have? 1, 0, 5, maybe 7, 2, 1, 6, 3, 9, 0, 0, 5. There is a matrix on your screens, and I'm interested in knowing how many rows are in this matrix. Chirabo?
There are 4 rows.
There are 4 rows, correct. So rows are counted like that. Someone can tell us which elements are contained on the third row. The elements that are contained on the third row. Isaac Newton had already told us that the matrix has 4 rows, which was correct. How many, which values are those? Julia, which elements are those?
We have 6, 3, and 9.
6, 3, and 9, correct. They are found on the third row. So that is very important to call rows by name. You should also know that. The next slide, we talk about columns, and columns run downward. So we have 2 and 4, we have 3 and 5. 2 and 4 is representing the first column, and 3 and 5 is representing the other column. So the above matrix coincidentally has 2 columns. And you can see the columns are here. The first column has 2 and 4, then the other one has 3 and 5. So I'm going to put someone example here. I'm going to put a very big confusing one, 2 minus 3, 6, 1, 1, 7, 6, 0, 0, 1, 1, 1. This is, yes, this is a big matrix. And how many rows are here and how many columns are here? Rows, columns. Rows, columns, rows, columns. Someone is using iPhone 8. Someone using the iPhone.
Master, the rows are 4 and the columns are 3.
Rows are 4 and columns columns are what?
3.
Columns are 3. Rows are 4 and columns are 3. Someone seems to be disagreeing or what? I see Mike's hand. Mike, do you have an alternative? Mike's hand is down. Julia?
Sir.
Yes, Mike?
I think the rows are 3 and the columns are 4.
I think the rows. Oh, the rows are 3.
And the columns are 4.
Okay. The rows are 3, the columns are 4. Okay. Can we try to see this? This is A, this is B. I want to see how many people agree to A, how many people agree to B. Maybe let's put that in the chat. I don't want us to debate so much about it. Are you going for A or for B? I'm going to relaunch this such that we can see. Okay, let's use the screen. Are you going for A or for B? I will use that to see who has got it right and who has not got it right. Are you going for A or for B? Are those 4 rows or there are 3 rows? Now the 2 are competing. 5 people have A as the correct against 13 people with B as their correct. Can we vote? Let's keep voting. 21 people have voted, 14 have B, and 7 have A. Okay, let's stop there. So let's stop the poll there. But I am surprised many people are still confusing the rows and columns. It's very surprising. We said the rows move across and the columns move downward. Maybe who wants to clarify that? Who has understood what is a row and who has understood what is a column? By show of hand, you try to say something, maybe you may help someone. Let me see. Yes, Ruth, you can say something.
Okay, the difference between a row and a column is that a row runs horizontally and then a column runs vertically. It does not differ with the normal English that we use when we have a column and a row, though people confuse it a lot. They call horizontal. If you're standing and then probably, let's use an example of a classroom. The desks are arranged in lines. You're standing in front of the class and then they're arranged in straight lines just from where you are. And they're going vertical, like straight from you. Maybe you stand and you can see desks well arranged. That is a column. And then horizontally, horizontal arrangement is say about it.
Okay, so she brings in the arrangement of desks in class, or maybe that one can help you. But what is important is that 2, 1, 6, and 1 down here, those are moving vertically and those are columns. We have 3 of them only, and I want to discourage the people who are giving the first answer, that is A, as correct. And I want to encourage B as the correct answer. Rows and columns are very important because they are going to help us know how to group numbers. I mean, how to get the orders of a matrix. And maybe we'll see that later on. But for now, there are only 4 rows and only 3 columns. Maybe for those who had not got that right. Then in the next slide, we talk about, there is an explanation here for rows and columns, but I talked about this earlier on. And if you're given A, B, C, D as the elements of the matrix, then they should be in lowercase, and the letter that is identifying that matrix should be in capital. It's very important. And maybe we need to proceed to the next slide. And because of time, I want us to quickly talk about the order of a matrix. Someone had talked about this earlier on. You people, if you're talking about the order of a matrix, you should know a row. You should, every time we are talking about the order of a matrix, we start by writing its row and we write the column next. So this refers to the number of rows and columns in a given matrix, and it's given by row by column. So if we have something like this, A is equals A, B, C, D as a matrix that we are using here, then maybe by show of hands, if you can now remember how many rows are here, how many columns are here. If you cannot understand how to get the order of the matrix, you would have missed the lesson. Chirabo, how many rows are here?
There are 2 rows and 2 columns, which means it's a 2 by 2 matrix.
Yes, this one becomes a 2 by 2 matrix like that because it has only 2 rows and it has only 2 columns. Joshua, your hand is up. You want to say something?
I think it can also be called a square matrix because it has the same number of columns and the same number of rows.
Yes, it can also be called a square matrix. We'll also see what a square matrix is. Thank you, Joshua, for that input. Then I'm going to put a quick one here. If we have 3, 2, 1, and we have 1, 1, 6. This one has how many rows and has how many columns? We want to know the order of this matrix. This is same hands. I don't want now same hands. Can we have some other new hands? Julia has been very participative. Isaac Newton has not said something. Isaac, you can give us how many rows are here? How many rows?
There are 3 rows and then 2 columns.
How many columns?
The rows are 2, and then the
how many?
Rows are 3, and then the columns are 2.
Okay, Isaac, I can't hear the last words.
2.
Kenneth, you want to say something, Kenneth? How many columns do we have?
The columns are 2.
The columns are 2. So this matrix is going to be called what? This one here. This matrix is going to be called a 3 by 2 matrix. So you can get as many matrices as possible and you give them the orders. I'm going to put another very hard one here. 2, 1, 5. Like this. Give me the order of this matrix. How many rows? How many columns? There's this hard one here. Now the hands are now few. Sharon, can you give us the order of that?
3 rows and 1 column.
3 rows
and 1
column. And 1 column. So which order is this?
3 by 1.
Yes, it's a 3 by 1. It's a 3 by 1 matrix. So people don't miss out anything.
Mr. Masava, in the chat, Trevor is is still putting emphasis on the 1 by 1. I don't know why. Maybe he has gotten where he has been lost from. So, Mr. Masava, do we say the, like what is now currently on the screen, do we say 2 by 2 matrix by word of mouth, and then in writing we just write 2 then times 2?
Yes, it is always just mentioned. You may not write matrix. If for like the one that is here, this is a 2 by 2. Those, like, this is something that mathematically has been agreed. If you write like this, you're meaning a 2 by 2 matrix in matrices.
Oh, okay. Thank you.
There is this terrible background music coming up. Hope it doesn't interfere that much. So the matrix above has 2 rows and 2 columns, and therefore we call it a 2 by 2 matrix if they ask you to get the order for that. Now, there are examples here. The first one is 1, 0, 2, 3, and that is obviously a 2 by 2 matrix. Then the other one is A, B, C, D, E, and F. And that one is a 2 by 3 because it has 3 columns. You can see the 3 columns. And then we have the other example here. This one is a bit abstract. It has 1, 2, 3 rows and only 2 columns. So this becomes a 3 by 2. We have a 1 by 2 matrix here, 1 row and 2 columns. You can see that D is a 1 by 2. And then part E is a 5 by 1 matrix. Make sure you understand that. And sometimes Chirabo, was that Chirabo who said, where do you stop? Do these matrices have a limit that I'm supposed to end on which row or which column? They don't end. That's why we can have an X by N matrices to show that I can write the N number. It can be 100 by 5 matrix, the order. So the number of rows is denoted by M and column by N according to that statement. The order is M by N. M by N means the number of columns, the number of rows are M and the number of columns are N. So if you realize that your matrix you've been given has 6 rows and it has 5 columns, where there is M, you put 6, and where there is N, you put 5. The order of a matrix is a very important thing we're supposed to talk about in this lesson. And I want you to write a few of these matrices down. I'm going to pick people randomly to tell us examples of the following matrices. Write down the matrices of the orders below. You can pick A, you can pick B, you can pick C. You write down, I'll pick people at random to tell us the elements involved in any of those ones here. Let me try to get order here. Okay, was tried out. You just sample out. You can sample B, you can sample C, and you tell us, I'm going to be ready here to annotate such that we see what you're thinking about. Julia, you're picking which one?
B.
Julia is picking B, and she's going to give us a 3 by 5 matrix.
Yes, I'm doing 1, 2, 3, 4, 5. One, two, three, four, five.
Mm.
Yes, again.
1, 2, 3, 4, 5 again. Okay. I thought you were reading through.
1, 2, 3, 4, 5.
Like that?
Yes.
Okay. 1, 2, 3. 1, 2, 3. Yes, those are 3 rows. 1, 2, 3, 4, 5. Those are 5 rows. You people, what is here is a 3 by 5 matrix, and that is the correct one. Who is giving us the next one? Who has not said anything here? There is a person called Jesse. Jesse, which
Yes,
one are you
please.
picking?
I'm going to do F.
F. Jesse is going to give us F, which is a 4 by 4 matrix. Go on.
I have the first column. We have 3, 6, 9, 3. The second one we have 3, 3, 3, 3.
3, 3, 3.
And then the next one we have 6, 6, 6, 6.
6, 6, 6, 6. Yes.
And the last one we have 9, 9, 9, 9.
And you give us things you can explain. Was this Mike? Who was that one speaking? Jesse.
Was Jesse.
Jesse, what does this mean? Are you talking about sugar, or you're talking about bread, or what is here? I see 9, 6.
Talking about number of mangoes given to.
Okay. Let's see the next person who can give us here.
Mr. Masal, let me help out.
Yes, proceed.
Let's hear from who hasn't spoken. Okay, Paul.
Yes, Paul, you can go on.
I'm doing part A.
First, hold on, I get your space. Part A.
The 2 by 3.
Okay.
Part A is a 2
by 3.
Yes, you can go on.
The first row, AZK.
A, Z.
The first row.
The first row, sorry. I had the column. It is A,
Z, K.
Okay.
And then the second one, E, P, J.
Yeah.
Yeah, that's it.
This is 2 by 3. Yes, correct. The columns are 2, and I mean the rows are 2 and the columns are 3. But can you tell us what it means?
Like what the letters represent?
These elements are representing what?
I actually don't know.
I don't know. This could be maybe the initials of names of maybe in a class, a group, or something. It can't lack a meaning. You must look for a meaning such that at the back of your mind, you know what you're writing. Can we get the last one, Ruth?
Yes, it's Sharon's hand that has remained up.
Sharon, which one are you doing for us?
I'm going to do for number E.
E. Sharon is doing E, and she's going to give us a 3 by 1 matrix. Give us.
The first row is going to have 1. The second row is going to have 2. The third row is going to have 3.
Yes, this is sorry. This is a correct 3x1 matrix. You can see there are 3 rows and 1 column. Maybe because of time, we will not pick out any other hand. And what is important here is if you can understand how to give the order of a matrix. That is all we're trying to look at in this particular example. And we are going to start with the addition of matrices. And because of time, I'll move into this very fast. Then we see how to add and subtract matrices. Now, you see that there is a matrix here. We have a matrix A and B. And A has elements here, and B has elements here. And they want us to get A added to B, if maybe that was the question. And if you're adding matrices, first of all, it should be of the same order. That one is a must. You cannot add a matrix that has a different order to another one that has a different order. It is just not possible. So we are adding A to B, A plus B. We get the 2 and add it to the 1 that is this side. We get the 0 here and we add it to the 0 that is here. And we can get the 1 and add to the 1 that is here. And those are the answers you're seeing, the 3, 4, 6, 0, 2, 3. On the other table that you saw, maybe the table that you saw the other side in the introduction, which had the families. The first family would be maybe the Mafavi, the Mwanga, Opi, and Cherop that you saw the first 4, and that could be Mbale people. Then we could have other families in Kampala, all of them uniting. Then we are adding to see how many kilograms are eaten of bread in 1 week. So bread cannot be added to what? To the maize. You cannot get this 5 and add it to 1 here, because on the other table, if I'm to just borrow that idea, this 5 was representing bread and this 1 was representing maize. So you cannot just add that together. So it has to be a 5 added to the 1 kilo of bread that is here. So 5 goes with 1, then this 1 goes with 1 here, and 1 goes with 0. And this is the answer you get. And there is a big note down here that matrices can only be added if and only if they have the same order. You can try to read more about that and know why is that so. And addition of matrices is not very hard, provided you understand that this is what is supposed to be added to this. Anna?
Can we add a 2 by 5 to a 2 by 3?
No.
Or it has to be a 2 by 3 to a 2 by 3?
It has to be a 2 by 3 to a 2 by 3. That one, there is no debate on that.
And in the other case, do we just leave it as the 2 by 3 plus the 2 by 5 and do not do anything to the matrices?
Yes, and if it is a question asked by a person, they may not just ask that unless if it is an error. But if it is in real life, then that one means you're adding things that are not possible. Like you're talking about bread, maize, and sugar. Then the other side, you're talking about only sugar and bread. You realize you can't add because it will confuse you. Are you adding bread to sugar, or you are like, it can't just work out. You just, I would rather say you leave it out. But I foresee such a question not being asked. If they ask it, then you can maybe conclude and say that because the order is not the same, we cannot get the sum of the 2 matrices. That is what I can say for now. Then when it comes to subtraction, if you're given matrices like this, we have A, we have B, and you're supposed to subtract them, then it is this 12. This 6 is subtracted from 12 here. We also maintain the positions like we maintained in the other example. And if they want you to get the value of A minus B, this is what we expect you to do. And that will be A minus B, which is 12 minus 6. 12 is blue, which is representing A. And this is wanted to put orange. Hope it is seen like orange or yellow. and it is representing B. So we get 12 minus 6. If they tell you A minus B, don't again interchange and say B minus A. You'll be getting different things. Ruth?
Okay, my question is about the format of the brackets. Do we use, okay, do they consider the brackets, depending on the two types I've seen you use when you're annotating, you use the normal brackets for the ones that are commonly used in English, and then this work here has
What I
the
can
box
say,
brackets.
what I can say here is that there are only two brackets that are recognized for matrices. The first one is this that I've been using, and because of the computer, this bracket is slightly bigger in computer. So when you find something is typed, in most cases, matrices are represented using this second bracket. But when a person is using a freehand, this one is easier, and both of them are correct. They are allowed. And don't go again and write sets. Don't go and say, they said brackets and you write this. This is for sets. Not allowed.
Okay.
So the two are okay.
So also I wanted to engage into the chat. There's an argument and some questions are coming through. So I think it was El Shama who asked that one. It's a bit obvious that can you have a matrix with zero columns? He said yes, a matrix of zero columns. He said, is there a matrix like 3 by 0? So we answered, a discussion continued that you cannot have anything that has no row. And then Joshua tells us that becomes a 0 matrix. And Favor's question, Favor also had a question in the chat.
That one becomes what? A 0 matrix? Did someone say that one becomes a 0 matrix? Let that one is not correct. Because a 0 matrix is not written like that. A 0 matrix, well, he has brought in a new term. A 0 matrix is the one that has only zeros as entries, but then even when there are zeros, they can have rows and columns. So this is a 3 by 2 0 matrix, for example. But if you say 3 by 0 is a 0 matrix, is not, whoever said that, they should withdraw that statement.
Okay.
Excuse me, sir. What about an identification matrix?
It's called an identity matrix. We'll also talk about that later on. An identity matrix. I have a lot of the types of matrices here that we will see later on. Continue.
Favor's question is, instead of being asked to work out A minus B, can't you be told to find the difference between A and B? So he's asking, what do you do when such a question is brought up?
The difference between A and B is, of course, A minus B. But I don't think they can ask it. I feel it is very confusing if they tell you to get the difference, because a person can get B minus A. And these two in matrices, they are not the same. So at least for the time I've worked with matrices, the rule is specify. If they want B minus A, they will tell you straight away. If they want A minus B, they will tell you straight away. And was that the only question?
I don't know whether, maybe Aris, you can raise your hand and you ask. I don't know whether he wants the difference in word format, whereby you're probably told to describe.
Can I have, yes, can you proceed? Was that Aris?
Okay. When you're talking about the difference between the two, yeah, you've basically clarified. When they ask for a difference, like you can, it's unclear because you can work out A minus B or B minus A. Either way, it's unclear, and yeah, he's clarified.
Okay. So, is there something else, Ruth, before
Then
I
can
proceed?
we, someone is asking, can you have a blank matrix?
A blank matrix like this?
Yes.
I've not seen that. I've not seen that before.
Then Alinda's question, leading diagonal 1.
Leading diagonal?
Yes, leading diagonal 1 and minor diagonal 0. Okay, leading diagonal 1 and minor diagonal 0, is it triangular or identity matrix?
Okay, let's hold on, because now people seem to be interested in the types. Because when you bring in leading, the minor and major diagonals, we are entering into a little out of what we are supposed to look at this evening. But then let me prepare something on the types. As someone who talked about the identity matrix, we always use it so much when we are solving simultaneous equations. I've never seen a blank matrix. Leading or minor, we'll also talk about that in types, but then we have, if there is a matrix like this, there are these diagonals. This one, there is 6 and 8 here. Then there is this other one. There is 11 and 1. One of them is leading and the other one is minor. I don't want to take you people there because many people are studying this for the first time. It may confuse them. What I wanted you to learn this afternoon was how a matrix relates to a real table. For example, a person who talked about a blank matrix, you would have not done research. That is not possible. You cannot go around looking for people. Your questionnaire has maize, it has sugar, it has bread. Or you're looking for people who have bicycles, cars, and maybe wheelbarrow, for example. And for you go to a certain family and they don't tell you whether it is there or not, then you would have not researched. So it is either 0. The least you can put there is a 0. You say, these people don't have a bicycle. These people don't take sugar. So it's a 0. But if you leave it blank, that one may not be there. Then the other thing I wanted to talk about was the order of the matrix, which we'll try to see. And lastly, addition and subtraction, which we've talked about. Chirabo, what is it?
Mr. Masawa, request for the previous slide.
Chirabo, what is it?
Yeah, I have a question. When you are getting the information from the table and putting it in matrix form, do the numbers in the row have to be the numbers? Okay, in the rows of the table have to be the numbers in the rows of the matrix.
Okay, I get it. We will see that in the next lesson. I will maybe try to emphasize that so much. But in most cases, they will tell you to organize your information in a 2 by 3 like this. So if your column had the 4, if your table was looking like this, I'm just using the previous table like this. If your table has something like this, maybe there is a 3, 2, 1, there is a 5, there is a 7, there is a 2 here, 1, 5, 0, 7, 6, 2. If that is your table, if those are your findings, and they tell you to write from this table, come up with a 4 by 3, they would have automatically told you to change. So a 4 by 3 means you're going to write 4 rows. So that would be 3. Let me use a different color. That will be 3, 7, 0, 5. Because they have restricted you to write a 4 by 3, then this will be 2, 6, 2, 1, and this will be 1, 5, 7, 2. And that will be the matrix, Chirabo. If they restrict you to write a 3 by 4, like this, then this will be just the same. 3, 2, 1, 7, 0, 5, like that. 1, 2, 2, 7, and this will be 6, 5, like that. So this one depends on whoever wants to read your table. And if the person who is interested in reading your table is specifically interested in a 4 by 3, this table will be inverted to look like this. This one has the same information. Then 3 by 4, it has also the same information, but it has been written in a different order. Julia, what is it?
Yes, teacher, I'm asking, is it okay, like I write from maybe the 4 by 3, you started with 3, 7, 0, 5. Is it okay I can write 5, 0, 7, 3?
No, that is now wrong.
Reason?
Because these could be two tables and you're going to need to add somewhere. Then you would have started to confuse the two tables. For example, this was Cheropu's column, this was Opio, this was something like that. Then in another table, they have the same. Then for you, you're starting to change to start with the 5. You're almost saying that now this was Wamafari is now 5 and this one is. So in the next table, you're supposed to do the same change if you're to add or if you're to subtract to get the right answers. I don't want to encourage it at all.
Okay.
Ruth? Ruth, your hand is up. Get there first.
Okay, I was just requesting for that previous slide so that I can screenshot.
This previous slide, I had forgotten. The previous slide had the addition and we were trying to add A and B.
Okay, finished, thank you.
Then this slide has, and also even in subtraction, you can only subtract if and only if they have the same order. If you realize the order is not the same, don't even start on them. But for multiplication, we will see, even if the order is not the same, there are some cases which will have the same orders and the other one does not have the same order, but it is possible to multiply. But for addition and subtraction, it is not just possible for you to add and subtract. Now, there are these questions that look like this. They will tell you to get the value of A plus 3B. Like that. If they ask you to get A plus 3B, you're supposed to get 12, 2 minus 3, 15, like this. On this, you add 3 multiplied by B. So where there is A, you put A. Where there is B, you put B. This is 6, 1, 11, negative 8, like that. So this will be 12 minus 3, 2, 15, like that. Plus, this will be 3 times 6 is what? 18. 3 times 6 is 18. This will be 3 times 1?
3.
This will be, here is what?
33.
33. And here
then
will be?
Negative 18. Sorry, negative 24.
Negative 24. 3 times 8?
Is 24.
Negative 24, like that. So then you add. They may give you something like that. They want you to add, don't fear them. Just substitute where there is the matrix A, where there is a matrix B, just do that. And I felt you needed to learn that this afternoon. I want to leave an activity behind. Then we had talked about a quiz after the lesson. I am not sure if it is very ready. Mr. Kaziba, is that quiz ready?
Yes, Mr. Lisa, it is.
Okay. So later on, we will talk about the quiz, and a link will be shared, and we see if we can try to apply what you try to learn here and get the answers correct. So can we take the screenshot of this activity? And if possible, you can get the answers and post them in the WhatsApp. We'll open the group later on. And this activity is got from book 3. I don't remember the page. Just take the screenshot. They are talking about matches. Where is the quiz? Someone is asking to be added in the WhatsApp group. Ruth, you may get Brina's number such that you add her on the WhatsApp group. There are these matches here for basketball, and there are those away matches, and there are those matches that are played home. For example, if Uganda is playing with Rwanda and they go to Rwanda, that is called an away match. If they come to Nambole, then that one is called a home match. For those who follow the Premier League, Arsenal, Manchester, and what, if they are at their stadium, that is a home match. Then if they go out of their stadium, it's called an away match. So here we have 3 teams. The first one is playing from home. That first column, that is black here. This one here. These are home matches. This is away matches. And they have tried to show you how they are playing. These are games played. This team has played 9 of them, won 5. They have made 3 draws and lost only 1 game. Then when they go away, they have played 7 away games, like that. So they want you to study this table and come up with 2 3x4 matrices. The word is 2 3x4 matrices. I expect you to be knowing now how to write the order of a matrix. And they want you to come up with a 3x4. Make sure there are 2 of them. You can call it matrix A, you give a 3x4. Then matrix B also give a 3x4, depending on how you'll understand this. Then you're supposed to use the matrices in Roman 2 to write down a matrix giving the results of all matches played by each team. Try to read this Roman number 3 and understand it, get its answers. Then part B is what is very interesting. You're supposed to just copy and you get the values, and you're supposed to explain how you obtained the missing matrix. There is a matrix here that is missing. How you get it, you must explain how you got it. The last one is down here, and they expect you to comment on your answers that you would have got after doing number C. And that is where I wanted to end this lesson. I want us to enter into the quiz session. You may not do these answers, this activity now. Just keep it. After the quiz, you will do it, and we want to see the answers on WhatsApp. I want to end here for now, and maybe Mr. Kaziva, if you're ready, we can proceed from there.
Thank you, Chair, for the lesson.
Thank you so much, Teacher Lisa, for the wonderful session, and thank you so much for taking us through on how we can do the matrices, addition, and everything. Thank you so much, and also the students, thank you so much. Okay, I'm just wondering. Okay, good. Now, Mr. Lisa talked about the application of matrices. And for me, my work, it is you people who are going to discover them, and then you'll know where we can use matrices in daily life. And one of the thoughts we are going to start with, for you, I'm just going to share the photos, and then I'm going to ask you to use the chat to type in where you think you can apply, or where you think matrices are being applied. though I'm going to give you some more ideas about it. I don't know whether you have ever wondered how they count the number of bottles that maybe they have produced in a day. So everything I'm displaying is a matrix. So when you look at the crate of sodas, let me use the chart. Who can tell us what is the order of those crates of soda? Just one crate. What is the order of that matrix for the crate of soda? Yes, Mike. I saw an hand up. Titan, Mike, What is the order?
4 by 7.
4 by 7. Okay, thank you for trying. Jesse?
So it is 7 by 4.
7 by 4.
7 by 4. Okay. Ruth? Sorry. Okay, it is 7 by 4. Very good. That is correct. Then some of you enjoy that game so much, but those games are applying. Those are matrices. The snake game, the chess game, all those are matrices. For you, do you know that transporting or carrying some things are really very hard? You know that none of you here can transport more than 80 eggs in your hands. But once you put them in some order, you know that you can transport them. So when you look at that tray, who can tell us what is the order of that tray? What could be the order of that tray? iPhone?
6 by 6.
6 by 6. Okay, thank you. Let me say, Stace Trevor.
The same, 6 by 6.
6 by 6. Jesse?
5 by 6.
5 by 6. Very good. Yes, that tray is 5 by 6. Those who have not bought eggs, those trays carry a maximum of 30 eggs. So it is not more than that. So, and
Wait,
those
Mr.
are
Kaziwa.
Yes.
According to the position of this tray, I think it's understood. I was going to say 6 by 5, yet we start with the rows. It's fine.
Okay, Ruth. So some of you always love to watch soccer, but when you look at these tables, they are using the matrices. And in order for them to calculate these points you are not seeing, these points here, always they use matrices to calculate them. But this one, we shall look at it when we reach what we call matrix multiplication. Yes, Paul.
I just wanted to ask, how do you yes, I just wanted to ask, how did you determine that it was a 7 by 4 crate? And yet, okay, it depends on the way you're looking at the thing. Because me, the way I looked at it was a 4 by 7.
Okay.
Not a 7 by 4.
Okay. All those two answers are okay. All those two answers are okay, depending on how you are taking the laws, and what you are calling your column. Yes, but the best thing now for such a case, always in most cases, the number of rows are many compared to the number of columns. In most cases, you find the number of rows are many, but all those two answers, whether you have said the 7 by 4 or 4 by 7, all of them can be correct. Yes, mainly for things that are the same. Whenever you find that the things are the same. So now, these are some of the few applications. But when you go deep, let me first hear from Jesse. Yes, Jesse.
It's talking about statistics and these, let me see, the ledger books they used to use those days. You could use matrices to sum up everything easily.
Perfect. Very good. Yes. So all those things, they apply what? The matrices. So we have very many, and those who are going to go into computer science, what? Those, but I wanted to just get for you the usual one, the common ones that you usually see. but those are few of them, but we have many. Yes, Paul?
Yeah.
Yes,
Yes,
Paul?
teacher, now you've confused me more. You said that the number of rows are usually more, but then the tray, you said it's a 5 by 6.
Okay, now, like what I'm saying, for the same number of items, you can, those two things can be, either you can call it depends on how you have put your tray. When I put my tray, let me put it like this. When you put your tray like this, you can say 1, 2, 3, 4, 1, 2, 3, 4, 5. Then you say 1, 2, 3, 4, 5, 6. Someone who has put a tray like this, it means that the number of rows you have, there will be 6 and you will have 5 columns. But someone can easily interchange the tray. So someone can put the tray in the other way around. Also, that one is okay. That's what I'm saying. So it depends on how you have positioned your tray, whether you have put it like this or the other round. Have you got it?
Yes, sure. Thank you.
So the way you place your tray is what matters. So good enough, I've seen people have started joining the quiz. So there is the link in the chat. Click on that link and then let us. Yes, okay, Paul, you're right. It depends on the way someone looks at the item. Okay, let's join. Click on that link. So far, I've seen 2 people have joined. Click on that link. Just click on that link. In case they're asking you for a code, then this is the code you are going to place in. Click on that. There are 26, meaning everyone must join. So once we get to 20 people, we shall start. There is a link in the chat. Just click on that link and should we start? I'm saying now so far 10 people. Oh, Sharon, click on it. Feel free to use any browser can work. Oh, yes, Paul, when you reach there, you are going to wait for me. I'm going to start it. So once I start, you are going to start seeing the questions. Yeah, so click on it, click on it. So if I'm seeing 11 people, 12 people. Members, should we start? Should we start? Okay, we need one more person to join, and then we can start. Just click on that link in the chat. Once you click on that link is going to take you somewhere. In case they're asking, those who are failing, you can as well go to joinmyquiz.com and then you put in that code. Okay. The rest who on the call, can we start? Are you failing? Kindly. Yes?
Let's start.
We start. Okay. Good enough. Now we have 15 people. The 4 that are remaining will be finding us. I'm just wondering why I'm seeing Aris. Alice, why are you not joining? Okay. So can we start? Okay, let us start. Please be mindful of the time. Some of the questions require you to think very fast. Otherwise, you may end up missing the question. So you can click in that picture to make it big. In case the picture is small, click in it such that it becomes big.
Shush. Take your nose away. Go away, I'm going to tell mommy. Eight, 9, 10, 11. 8. Up there.
Vegeta quizzes.
Don't wanna let you out of my head. Where you welcome my life, where you welcome my life.
Biana, stop shouting for us. You don't know how to sing.
Okay, I think that is the end of our quiz. So maybe we are waiting for the winner. So that's our quiz. So Moulia Jesse was the best, followed by Brianna, and then Chirabo Park, and the marks. Those are the marks. I'm not saying some of you failed because you missed out a few questions. There are some questions that were missed. That's what made some of you not complete. Yeah, that was the only challenge. Just because whenever this one shows that someone did not complete. So we are going to end there for today. I want to wish you a good evening, and let's meet tomorrow for that talk. Unless someone has something to say.
Yes, Mr. Kazimba. Yes, teacher, I have something I want to ask.
Yes, Julian.
Like, teacher, on Friday, the timetable indicates blank. So what are you going to do? Like, suggestion of project work.
Oh, you are suggesting we do some project work?
Yes, more especially in like, okay, any subject that you pick.
Okay, good. Let me hear from Chilavo.
Do we have lessons next week?
No, Pal. I think next week people are going back to school.
But then some are remaining.
Oh, maybe it will depend on how many are remaining. Because what I know, some schools are starting next week. Yeah, but we shall plan and see what we can do. Okay, so let me see how our program will be on Friday, whether we can handle some project work.
Yes, sir.
Okay, let me wish you a good evening, people. Bye-bye.
Bye.